What is AQL sampling? The source of AQL sampling table. What is OC curve? And what is confidence and reliability for sampling? We will explain this with an example. Tommy is a development engineer and he manufactures tubes with 1-inch diameter. He has an order of 10,000 pieces and produce them in batches of 1,000 each. The specification required by customer is that the outer diameter of the tube should be 1 inch plus minus zero point 0.1 inches. When he produced all the batches, he would deliver them to the quality and quality would inspect the parts. The AQL is 1%. That means only 10 pieces out of 1,000 could be out of spec for that lot to be accepted. When they inspect all the parts, they notice that 8 lots are passed and 2 lots were rejected. So 2 lots, they have samples that are more than 10, there are more than 10 samples that are defective. And we can plot that graph here. So 8 points on 100% and 2 points on 0. Now, Tommy received a bigger order, that is 40,000 pieces. And this time the cost of inspection for each part has been increased. He has to find a way to produce the part and reduce the cost at the same time and maintain the quality. He asked an expert for advice and a quality expert recommended him to use a sampling system. So when we look at this table, the AQL sampling system, for a lot size of 1,000 pieces, an AQL of 1, the quality expert recommended him to use 34 sample. And provided that all these 34 samples would pass the specification. So basically C is 0, no reject. And this looked like a better option considering the time of the inspection that has been consumed for each part. But where is that 34 samples coming from? I mean, what is the basis of that 34? Why not 50? Why not 90? To explain that, we have to introduce the OC curve. That is operating characteristic curve. We explain that with the sketch here. So we have two zones, 99, 1%. 99 is a good zone, white zone that we are conforming. 1% is that non-conforming zone. What is the probability of acceptance? If you spin 34 times, that's your sample size basically, and every 34 times you land on 99. So every time that you spin, you land on a white zone and you're passed continuously, like 34 times. You can calculate that using binomial distribution. I mean, mathematically, there is an equation for that. And if you use that equation, you get 71% probability of acceptance. And you can plot that point here on the left, 71% for 1% AQL, right? And then you can increase your red zone region, right? So you go to a bigger, like go to 2% and 4% and do the same exercise. 34 times spinning. And what is the probability? And you get more points for 2%, 4%, 6%, and basically you can plot the curve. And I have shown here a snapshot of the Excel spreadsheet that you can use to plot this curve. As you increase the red zone region area, I mean, your probability acceptance would go down. That is kind of obvious because now you have more chance to land on non-conforming zone. So you can, in the next step, you can plot this curve for different sample size. So you can use more spinning, right? So instead of 34, you go to 45, 55, and 60, and then you can plot the curve. But you can see that when you start going to 34 and above, the shape of the curve on the left becomes, they are getting closer to each other. So 34 is kind of an optimum number, right? Considering the number of the samples that you have to test, and that's how that 34 sample has been established. So the expert, they have reviewed the numbers, they have looked at the lot size, and they say, oh, based off what we consider as a probability of acceptance, that 34 sample is selected as a sample size for that lot, size. So that's the basis of that 34 samples for in that table. And you can plot that curve or calculate those numbers in Minitab. So you go to Minitab, Stat, Quality Tools, Acceptance Sampling by Attributes. And you can see that as you go to a bigger sample size, your probability of acceptance would go down. And that's kind of obvious. I mean, you're spinning more, right? As you spin more, eventually you will land on the red zone region and it will be kind of reject for the lot. Now we define the confidence and reliability for sampling. So confidence is 1 minus PA, that is, PA is a probability of acceptance. So confidence basically is probability of rejection. And as you spin more, as you do sampling more, your confidence would go up. Reliability is 1 minus rho, and rho is non-conforming rate. So basically your reliability is conforming rate. Remember that confidence and reliability define the customer risk when inspecting X number of the units and allowing Y number of the non-conforming unit. Basically, you are not inspecting 100%. You are now inspecting a fraction of the samples. And based off the probability function, you provide a confidence and reliability basically. So one important other thing that we have to explain is for process validation, based off the risk that you have and defects, you define a certain sample size, a minimum sample size basically. And let's say for you have a medium risk and a major defect, and your confidence reliability is 95-95. If you plot the different sample size with C0, you will find that at 59 you will have a match for 95% reliability and 95% confidence, basically your vertical axis and horizontal axis. And that's how the 59 sample size is set for 95-95. If you go to a lower risk, right? So if you go to 95% confidence and 90% reliability, if you plot the curve, you can see that 29 sample would match this. So basically that 59 and that 29 sample size for process validation are calculated based off this. We have to remember that the confidence and reliability explained here are different from the confidence and reliability defined for a tolerance interval calculation that is provided here in blue. Basically, there are two different concepts, and we will explain that and we'll discuss it in next video in our channel. Thank you so much.